All right, so two things can happen when we have objects interacting. They can either explode or they can collide. We're going to talk about what happens in both situations. So in an explosion, an object breaks apart. Into more than one piece. A great example of this would be a firework. And that's why there's a huge firework on your piece of paper. So we have a firework, we have one object, it explodes, all of that momentum has to be contained in all of the pieces. So the momentum of all of those final pieces added together is going to equal the initial momentum. So let's apply that to a problem really quick. It says a 12-gram balloon explodes into two pieces. So we have two pieces and we started with 12 grams. All right, a 9.5 gram piece flies 8.1 meters per second right. Find the momentum and velocity of the other piece. So we know what one piece did after the collision. We need to find what the other piece did after the collision. So we have momentum, total initial, and we know because of the law of conservation of momentum that it has to be equal to the momentum total final. And for the sake of positives and negatives, I'm going to say that left is negative and right is positive. That's going to help me keep this piece right here that's flying to the right positive and make my numbers a little prettier. So the mass total initial velocity initial is equal to mass 1 velocity 1 final plus mass 2 velocity 2 final. So all I did was break momentum down into momentum is mass times velocity. Our initial velocity was 0. That balloon was stationary before it exploded. So if this is 0, I'm going to put a big 0 over here. So I have 0 equals mass 1 velocity 1 final plus mass 2 velocity 2 final. I can simplify this and say negative mass 1 velocity 1 final equals mass 2 velocity 2 final. My initial mass is negative, or my mass 1, sorry, is equal to 9.5 grams, but I need that in kilograms. So 0.0095 kilograms times 8.1 meters per second equals mass 2 velocity 2 final. Negative 0.07695 kilograms times meters per second is equal to mass 2 velocity 2 final. So mass 2 velocity 2 is the same as momentum. So I can go ahead and say M2's final momentum is 0.077 kilograms meters per second. That's negative, so it's going to the left. All right, my final velocity is negative 30.78 meters per second. equals velocity 2 final. We can figure out the mass of 2 by saying we had a 12-gram balloon. The first piece was 9.5 grams. So we can subtract and get the weight of the second one and then solve for velocity 2 final. So the velocity 2 final, or the velocity of it, is 31 meters per second to the left. All right, so let's talk about explosions. Let's talk about collisions. Let's grab a different color. So collisions. So all of the explosions are up here. And this whole bottom part is going to be collisions. I probably should have colored this first. All right, so a collision is when an object impacts another object. So an example of this is bumper cars. Bumper cars are fun. We all like to play on them when we were little. Even as adults, people like to play on bumper cars. And if we don't have bumper cars, we like to run things into each other, whether it be skateboards or bicycles. Please don't actually try any of that, but I'm sure some of you already have. So we have two bumper cars of equal mass, and they collide. Initially, their velocities are 3.7 meters per second east and 4.3 meters per second west. The second bumper car's final velocity is 2.9 meters per second east. What is the final velocity of the first bumper car? So they're of equal masses. So because they're of equal masses, I can say mass 1 is equal to mass 2 is equal to m. It's all equal. So when I write out my formula, mass, velocity 1 initial, because it's all equal, I'm not going to write out mass 1, mass 2. It's all equal. It's all the same mass. So mass, velocity 1 initial plus mass, velocity 2 initial is equal to mass, velocity 1 final plus mass, velocity 2 final. Mass is the same in all terms. So mass cancels. That leaves me with velocity 1 initial plus velocity 2 initial is equal to velocity 1 final plus velocity 2 final. Velocity 1 initial plus velocity 2 initial. I'm going to go ahead and bring over this minus velocity 2 final is equal to velocity 1 final, because that's what we're solving for, the final velocity of the first bumper car. Then I'm going to plug in what I know. So I know that velocity 1 initial was 3.7 meters per second east. So I'm going to go ahead and over here somewhere say east is positive, west is negative. So I have 3.7 meters per second plus velocity 2 initial is 4.3 meters per second west. I'm going to take the inverse of that, 4.3 meters per second, because it's in the opposite direction, minus 2.9 meters per second equals velocity 1 final. So velocity 1 final is negative 3.5 meters per second. So I can say, therefore, the first car's final velocity is 3.5 meters per second. It was negative, so it's going west. And that is all there is to conservation of momentum in one dimension. So it's really pretty easy. It's really pretty linear.